Now we're going to look at trying to determine whether a compound statement is true or false based upon the simple statements that it's made out of. Of course, simple statements themselves can be true or false, and so without knowing which one it is, we have some options at stake. And so just take an example here, and we're going to use tables to organize our thoughts. Okay, so just to clue you in on what's going on here. Okay, so this is called truth table basics. Really, we're looking at truth tables for negations, conjunctions, and disjunctions. So kind of your three more basic connectives. Okay, so I'll just start with one statement. I visited Big Bend National Park. Now that could be true or false. I'm not going to tell you yet whether that's true or false. Okay, so we have two options for P. Now in the table form, what I would do is I would say, well, here's P. It could either be true or it could be false, right? Those are my two options. Can't be both and it can't be neither, right? In order for this to be a statement, which it is. Okay, so then we look at other, the negation of P, all right? So if this statement is true, then its negation, not P, must be false, right? So by definition, the negation of a statement, of a true statement, is false, and also the negation of a false statement is true. So not P is of course the statement, I did not visit Big Bend National Park, right? So either the first one is true and the second one is false, or the first one is false and the second one is true. Okay, they cannot both be true, they cannot both be false. Okay. Yeah, so these are our options, right? So all right, each row of the table essentially is what we could have. That's the option. Okay, now let's add in another statement. Let's say, let's call it Q, statement Q. And let's do, I visited Carlsbad. Gotta spell it right. Caverns National Park. Okay. Again, could be true, could be false. So we've got options here, right? So now we can look at combinations of P and Q. We could look at their, we could also look at the negation of Q, right? So we could have Q is either true or false, and not Q is either false or true, respectively, right? So if Q is true, then not Q is false, and if Q is false, then not Q is true. And not Q, of course, is I did not visit Carlsbad Caverns National Park, okay? Now let's say I were to start combining these into conjunctions and disjunctions, okay? So using an and or an or. I'm going to set this up over on the other side. So we have the truth of P and the truth of Q. We don't know necessarily. P could be true, Q could be true. P could be false, Q could be false. So there's some options. Now it could be the case that one is true and the other is false, or that both are true, or that both are false, right? We don't know. So we've got to write out all those different combinations. The way I like to organize this is to say, let's say Q is true or false, right? Could be either true or false. Well, the truth of Q could be associated with the truth of P, and Q being false could be associated with P being true also. Well, what happens if P is false? I'm going to have two more options, right, for Q. So So if P is false, Q could be true, and if P is false, Q could be false. These are the 4 different combinations that we can have, okay? We can have both of them true, both of them false, or one of them true, the other true, okay? Yeah, so that's all the different combinations. Now the number of combinations is always going to be based upon the number of simple statements that we have up here, okay? So if I had another statement R, for instance, which I don't have yet, but we could add an R in later, then you'd have to basically repeat that. You'd have to have these options for R being true, and then the same set of options for R being false. You double the number of options every time. And so what you end up with, the number of options, or you could just simply say rows in the table, will be equal to 2 to the n power, where n is the number of simple statements. It's supposed to be ERE. Where n is the number of statements, okay? So here I've got 2 statements, so 2 to the 2 power is 4, and that gives us these 4 options. If I had 3 statements, like I add an R in there, then you'd have 2 to the 3rd power, which is 8, right? It doubles. You take the 4, double it, you get 8, okay? And so on. So it's always 2 to a power. If I had a 4th simple statement, you'd have 16. You have a list of 16 options or 16 rows, because you take the 8 and you double that again, okay? So it's a continuous doubling effect. Okay, now, let's say I wanted to combine these. And let's say that I wanted to combine them using a conjunction, a P and Q. Okay, P and Q, in this case, would be the statement, I visited Big Bend National Park and Carlsbad Caverns National Park. Okay, well, that statement can only be true if both of the simple statements are true, right? So if both P and Q are true, then the conjunction is true. But if I'm lying to you on one of these, and it's not true, let's say I didn't actually visit Carlsbad Caverns, then the conjunction is false. Then it's not true that I visited both, right? If I said I visited Big Bend and Carlsbad, but I didn't visit Carlsbad, then the statement I made would be false. So one being true, the other false, makes the conjunction false. Same here. If it was false that I visited Big Bend, but I did visit Carlsbad Caverns, then the conjunction is still false. And of course, if they're both false, then I'm just really lying to you, right? So the conjunction would also be false. So conjunctions are only true when both parts of the simple, both of the simple statements are true. So conjunctions are only true when both simple statements are true. Okay, conjunctions are false all the rest of the time. All right. Now let's take a look at the disjunction. Okay, the disjunction would be P or Q. And that would be like me saying, okay, I visited Big Bend National Park or Carlsbad Caverns. Maybe I couldn't do both for some reason, or maybe I could do both. It doesn't matter. The or, remember, the disjunction allows for both, one or the other or both. So if I made the statement, I visited Big Bend National Park or Carlsbad Caverns, it would be true if I visited one of them, it would be true if I visited the other one, and it would be true if I visited both. Okay? So, if P and Q are both true, then the disjunction is true. If one of them is true, then the disjunction is still true, right? I've visited one or the other. If one is true, then the whole statement is true. If P is false and Q is true, again, likewise, the OR statement is still true. You only need one of them to be satisfied. However, the disjunction is false if both of these statements were false. So if I hadn't visited Big Bend and I hadn't visited Carlsbad Caverns, then when I say I visited Big Bend or Carlsbad, that would be false, right? So if I hadn't visited either one. Okay. And so now we have a truth table. This is a truth table for a disjunction. The disjunction is always true unless both of the simple statements are false. Okay. And so as another way to describe disjunctions, I could say disjunctions are only false when both simple statements are false. Okay, so conjunctions are only true when both are true. Disjunctions are only false when both are false.